When resources were scarce, our ancestors crossed the seas. And when the world needed energy, we rose to the occasion. Today, humanity stands at a new crossroads. A growing world demands new frontiers. And like our ancestors, we heed the call to explore. The same spirit that built the oil age will harness the energy of the universe to create a sustainable future on Earth. Our ships have changed. Our spirit remains.
Today's guest is Daniel Varming. I met him for the first time during the Ultra Festival in September 2025. And throughout the session, Is the Future in Space? I was immensely impressed by Daniel. As a computer science student at the University of Stavanger, he started and scaled the student organization UIS Aerospace from 1 to more than 100 members in only 4 years. As they expanded the organization, he talked enthusiastically about going from tiny toy rockets on campus to what happened when they launched the 8-meter tall rocket Phoenix 1 from Utsira spaceport. Daniel also co-founded and has served as part-time COO at the Norwegian space technology collective Norstech. This is an initiative to advance national space capabilities across schools and universities in Norway. In December 2025, he co-founded Spacelab, a company originating from UIS Aerospace, and took on the role as CEO. They will build Norway's next-generation launch capability focused on reusable rockets, sustainability, and competitive space access. Already in 2027, they plan to launch a satellite into orbit as they work towards their mission of establishing a national commercial small satellite launch service from Norway, and in doing so, enabling sovereign access to space for Europe and beyond. And now, dear friends, my conversation with Daniel Varming. All right, welcome to the pod.
Thank you very much. Thanks for having me.
It's a pleasure to have you on. And I think, first of all, I would like to ask you, maybe you can tell me about how you got interested in rockets in the first place. And perhaps you could share the story of the first rocket launch on campus.
Right. So ever since I was a kid, for as long as I can remember, I've been fascinated by aircraft, and actually in later life, more of an acquired taste, rockets. But always liked the concept of, the freedom that ensues if you can fly is just really fascinating. And so what I did was I was studying a bachelor's degree in computer science at the University of Stavanger, and I was I was quite bored. Not necessarily because I was a really good student, but more of me needing to do practical things with my hands in order to learn. My learning does not necessarily come from only reading books. I really have a need to go out there and do things that I can, so that I have somewhere to, apply the knowledge. Because just knowledge for knowledge's sake, to me, is, of course, it's necessary in some regards, but it's what you can apply. That's really the measure of how good your knowledge is. Can you apply that knowledge to do something? And so I figured out that there's nobody building rockets at this university, so I started a club and got 4 friends to have a stiftelsesmøte, a founding session,
Yeah.
and we applied to create an organization. And I thought, okay, the first thing we have to do is we have to do something, right? Anything would be better than nothing. So we actually went to a professor, kind of crazy professor at the university, Inge Christ, and we asked him, because we had heard that he had been involved in some rocket construction way back and had spoken at NASA in a training camp in Turkey. He's a regular speaker in Turkey at that space camp. So we went and asked him, would you happen to know, very carefully, would you happen to know who we can talk to in order to possibly see if we can get some rocket engines? And he was like, Daniel. And he turns around and he grabs a box from his shelf and he says, why don't you just take these?
Oh, wow.
And he had a bunch of little rocket motors that he gave us. And so we run out the door. A guy at the university called Didrik helped us 3D print the rockets we designed. And we put these little engines in, and we found great fun in launching these rockets at the university. It was a terrible idea. So we did it about 5 times. And we were realizing more and more how bad of an idea it was while we were doing it. These were small, but we put metal in the tips and to try to make them fly straight, and we're mastering like the basics of it. And they went about, some of them went about 40 meters up in the air, but they went 500 meters the other way, or
horizontally,
200 at least. Yeah. So the apogee wasn't great, but the range was decent. So we found out that was maybe not a good idea, and then we decided to establish our own launch site, a test range for model rocketry. And then we had 3 very successful years where we launched first a 2-meter 3D printed rockets, and then a larger, some 4-meter Borealis rocket, as we called them, that were solid fueled rocket engines that we launched from this test site. And we invited the public and media, and we made it like a field trip, and invited friends and family to come see it. And these rockets were quite powerful, and so it was a nice show for people to come and watch. So that's sort of how we got started. I would say that's the sort of founding years of UIS Aerospace, where I've had the pleasure of leading that organization now since the very first day up until now, actually, where I'm in a transition phase into this commercialization of UIS Aerospace that we're working on, which is called Space Lab.
Really, really cool. As you are describing, there's been a tremendous growth journey to this first founding of UIS Aerospace, where you and a couple of friends putting it together, and now it's a rather large organization. Maybe you can take me through a little bit in more details around each consecutive rocket launch and the learnings that you have had from each rocket launch, and what you sort of incorporated into the next launch, and how you sort of both build out the rockets and their range, but also the organization as a whole.
So we have a principle in UIS Aerospace, and it's based off of a quote that I don't know who to attribute to anymore, but it's fail early, fail often, but always fail forward. And that's a very important part of why we have succeeded as a student organization in UIS Aerospace. Or that's up to us to decide. So we have decided we have succeeded, because we do accept technical risk, in a sense that we're okay with failing. We think failing is a very important step to becoming successful and achieving anything, in life even. So failing is our best friend. We just have to make sure that we don't keep repeating the same mistakes over and over. And that's sort of that was the key, the leading principle in the early years of UIS Aerospace, was just, we don't know what we don't know. We have no clue. It's not that we don't know how to build rockets. We don't know what we don't know about rockets. So we need to just gain experience and do something in order, you have to start somewhere. And
Yeah.
you start by making a small one, and then you scale that up, but you have to start somewhere. So in the beginning, that's what we did. We just failed a lot. We got really good at failing and finding stuff out. And so the Didrik programs, they were a bit, we call them sort of the unofficial, the black ops of UIS Aerospace, because we launched them around campus, and thankfully nobody got hurt. But we did hit a car once, and we ran really fast the other way. So if somebody notices a bump on the roof of their car, you might want to.
Did you also
Might
hit
know where
a
to
hit a
go.
house at some point, or am I?
Yeah,
Yeah.
we hit Hulda Gabolkshus. I think we hit the side of that building. We think, at least, because the sound came from there, and it was a thump. But we didn't break any windows or anything, so that was good. But then we moved on to this 3D printed rocket, Tyr 1, which was more powerful. There's a funny story there from when we ordered the rocket engine. I was sitting with a ruler in my office, and I was thinking how, because we didn't know anything at this point, how thick, what diameter rocket motor should we order here? And I was thinking, 15 centimeters sounds about right. 150 millimeters. Yeah, that sounds about right. We can do that. So I write an email to this European model rocket store supplier, and I tell them we want to order your Pro 150 rocket engine, and we have a payload of about 1 kilogram, and we're going to an altitude of about 2 kilometers or more, and that's what saved us. And he wrote an email back, and he was basically like, "Do you have any idea what you're talking about? Do you know what you just ordered? You just ordered the most powerful commercial model rocket engine out there on the market, and you want to send a kilogram. This thing is gonna fly at like 5,000 kilometers per hour, and what the hell are you guys doing?" And so we actually we made a new email address. And we actually did the math for what we actually needed. We made a new email address, and we sent him a new email with what we really wanted, which was a 38 millimeter, not 150 millimeter. And that still went to about 1,000 meters. And we learned some lessons there about parachute deployment mechanisms. That's really, we found out that the hardest part of launching these rockets is not getting them off the ground necessarily. It's getting them back,
Yeah.
because what goes up needs to come down. It's going to come down in one piece, but it'll maybe explode in many millions of pieces, unless you have built a robust parachute system. So that's what we found out. That was sort of our model rocketry days, and we found out that's really hard. And then we built a parachute system that was more robust, but that failed. But it was a different mistake. It was a different failure, so that's good. And then with Borealis 2, we finally managed to recover the rocket. It was actually, we were helped by the special forces who were training in the area
Oh wow.
of the launch, and they included this as a part of their. They made it like a case, as if there was an actual hostile rocket launch in the area.
Ah, that's really cool.
And they used it there. We had used weeks to find these rockets again previously, because the terrain was so rugged. And right after the launch of Borealis 2, I got a call from the I think it was a captain in the the sniper, in charge of the snipers that were there on exercise. And about like 30 seconds after landing, he called me and he says, "We have it." And I mean, what do you mean you have it? "Oh, we have it." And I asked him what the price was for getting it back, and if he wanted a bottle of champagne, and he said that our services are free for the citizens of this kingdom. He said,
Oh
which was pretty cool. And we were starstruck. Everybody was Everybody thought it was cool that they were, we went to pick up the rocket from them. And that's the first time we actually managed to recover something. But then Phoenix 1 comes along. It was the first liquid fuel rocket that's ever been launched by students in Norway. So very powerful engine with 1.6 tons of thrust. Very powerful thing that can lift your Mini Cooper straight up if you wanted to. Not that you would want to do something like that. But
Who knows?
but yeah, it's a very, very powerful rocket engine that we were very proud that we managed to build. And on that particular one, we spent so much time on the rocket system and so little testing the parachutes that we had a very hard impact. And we still actually managed to recover the whole thing. But that was more thanks to us dimensioning the rocket so that it actually survived about 500 kilometers per hour dive into the sea. And then we picked it up in a boat afterwards.
And the Phoenix 1, in terms of size, that was about 8 meters, something like that, 250, 300 kilos, something like that? Or
Yes, 250 kilos, 8 meters, and a diameter of 250 millimeters, of 25 centimeters.
Oh, that's quite big.
So quite big. I think it might even be the biggest, or at least one of the biggest student-built rockets ever in history, especially liquid fueled. It is very, very sizey. So we're happy with that. That goes towards sort of the whole goal of UIS Aerospace is to give students experience in what we think will be a key to live sustainably here on Earth, and that is space technology. It's something that people view as, many people think that space is very distant, that it's something we're going to be maybe living off in the future. But the reality is that already in society, we have critical infrastructure that's reliant on space systems. If you're rescuing someone in the North Sea or anything, rescue operations or whatever, you're using satellites and GPS, and you're using, if you're calling someone over the horizon, you're using satellites to call, and yeah, it's already, our society depends on space infrastructure, but there's so much more to that. And you had Brage Johansen on your podcast to talk about.
Correct.
I'm sure he talked about the moon.
Yeah, for sure.
If I had to take a guess, and that's really something we see also. We want to prepare, especially Stavanger and this region that we are in, Rogaland. We want to prepare for what we think is inevitably coming, which is a new industry that we're going to be using to make life on Earth sustainable.
Yeah. The space industry as a whole is growing tremendously globally, but also quite a lot in Norway as well. And we definitely need to be part of that space journey. And it's very inspiring to see what you've been able to do through UIS Aerospace and growing that organization from that humble beginnings. And the first rockets being, I'm guessing here, but maybe 25 to 40 centimeters. And then only how many years after that did you do the Phoenix 1, which was 8 meters?
We launched the first rocket in August 2022, and then Phoenix 1 was in June of 2025.
That's quite impressive. I mean, all the iterative work that made you able to pull that off in only 2 years. I mean, that's quite a journey.
A lot of fucking around and finding out.
Yeah, for sure.
The key.
And at this stage, what's the current size of the UIS Aerospace organization now?
We're 105 members this semester, and then we might grow even a little more. But we're quite happy with the size of our team now. So I don't think people-wise, like, we're gonna have to grow much more, because now it's more management. Realizing the potential of the members you do actually have. In the beginning, it was like, oh, we actually need 30 more people for various tasks. But now it's more about, motivating and making sure people work together towards the common goal instead of, working around each other and stuff. So it's much more become a management thing. So I think we're pretty happy with the size we have of organization now. That's where it's probably going to be at in the years to come.
Definitely worth noting that you went from about 3, 4 people to 105 in roughly 4 years, if I'm getting that right.
Yeah.
That's quite impressive. One thing we haven't talked about or touched on that thus far during that journey is also, if I'm getting this right, in around 2023 rather, you founded or were part of founding Norstech. Maybe you could speak to Norstech and sort of what's the purpose of that organization? How did it come about?
There's this great conference that's it's owned by Ole Dokka, which actually lives here in Stavanger in Sola. And Spaceport Norway is sort of a melting pot for everything space in Norway, and actually on an international level too. Now there's representatives from NASA and the European Space Agency and Japanese Space Agency. It's a really cool melting pot. And in this conference, we were invited. We heard about Ole through the grapevine here at the university, and we got in contact with him, and he invited us for free to come to this conference because he supports students, and there were about 100 students participating. And what we experienced was that during this conference we met so many other people, like-minded people, that it accelerated UIS Aerospace in a way where we would never be where we are today if it weren't for that one thing we did, which was participate at that Spaceport Norway 2022 conference. And we met Propulse NTNU, which is a student organization that also builds rockets that we since have been looking up to, and now are sort of in a space race with, which we think is pretty cool.
Nice.
And really people that knew more than us about rockets, right? And so we started out not knowing that these people existed, but then when we met them, we sort of realized that, oh my God, we have so much in common. We should get together more often. And that was the whole thing that started Norstech, which stands for the Norwegian Space Technology Collective, was that we were having such a good time and learning so much from each other, from meeting up and, talking about the space industry and space technology, and how did you guys solve this problem? And how did you guys build your parachute system? That we figured out we need to make a national collective for all students involved in technical space activities. And so we founded Norstech. And the sort of story for Norstech was quite funny. It was that Stian and I, who was the vice president of UIS Aerospace at the time, we were running around this conference, like two golden retrievers in a dog park, just talking to everyone. And we met this U.S. Space Force Major General John Olson. The Americans are so good at small talk, and they're so good at socializing. Man, they're geniuses in that regard. So we're so starstruck by these people immediately. And we start talking to them, and he's flown every fighter jet in the world, and I asked him, like, what do you think we could be doing better to like accelerate space in Norway? And I told him about our desires to launch at Andøya, which were problematic at the time because it costs a lot of money to do that. And he said, you guys should join together, right? You should stand more united as students. That's going to give you a lot of leverage. And so we immediately acted upon that. Told people we were going to start a something. We didn't know what it was, but we were going to do something.
Yeah.
And then I talked to Freidar Fløan at that conference, who is now the president of Norstech. And we told him about this idea, and it turns out they had already had this plan for a long time. And they told us, like, okay, Daniel, basically, Daniel, slow down. Let me tell you about something. and he told me about what they'd been working on, and then we sort of decided that our paths were joined from then on, and we joined them in their project that they've been planning. And we signed a contract on a napkin that very that same evening, I think,
Love that.
or at the end of the conference, with all the leaders of the technical organizations of students. And then that napkin sort of became, it's still a trophy that Freder has at his home. He's like,
Framed
I
it,
think he's
or
framed it. Yeah.
yeah, lovely.
And that started Norstech, and now we've signed a launch agreement, or not a launch agreement, that would be wrong, and a letter of intent with Andøya Space to establish a student launch pad at Andøya Space, so that we can ensure that you have a place where students can go and safely launch these rockets every year in Norway, to really build and foster, not only space technology, but just STEM and science, to be sort of we call it the ildsjelfabrikk in Norwegian, that you produce a producer of fiery souls. That
I
you
love that.
make you give people, you inspire people to pursue technology, and
Yeah,
in
and
a way
then
that you let them do cool things.
and an avenue to sort of play it out or let it play out. I mean, that's amazing.
Yes. So that's where we're at with Norstech now, and also this summer, where you're invited, by the way, to come and see. We will have 4 launches from Utsira, which is the spaceport that we call it a spaceport, but it's more of a test launch site. But we call it Spaceport Utsira, where we launched Phoenix 1, and it's sort of a testing ground for rockets, and we'll have 4 different rocket launches from different organizations at Utsira in this summer, and that is a Norstech thing. So that is part of this initiative that we have, a launchpad initiative, to give access to launch sites to students, and Norstech through UIS Aerospace will be hosting these organizations to launch the rockets, and it's also a precursor to the rocket challenge that will be up at Andøya in hopefully in 2027.
Yeah, I think this is a good segue to this satellite launch goal that you've talked about in the past. It sounds incredibly ambitious, and I love ambitious plans. And I think maybe you could help us understand more of the details of the size of this rocket and the overall plans for this satellite launch mission.
So what's happening now is that we've founded a company from our experience in UIS Aerospace. We have now founded Space Lab, which is a commercial continuation. It's basically, we're done studying, we need jobs, but I'm not gonna go and apply for a normal job. I need to build rockets. We're gonna put a satellite in orbit of the Earth with a Norwegian built rocket. Our plan is to use all our technical experience from UIS Aerospace, scale up everything quite a few notches, and then produce a rocket that can orbit the Earth. And that rocket we call Valhall, from the Viking, hall of
Of the
the
gods.
gods. Yeah. And
It's a fitting name.
yes, we figure we have to use our Viking heritage, because we're not going to be doing plundering the way the Vikings did, but the same spirit of exploration and courage is what you need to have when you're going out and pioneering something like this. So
Absolutely. I
so
love
we're
that.
gonna use that same spirit with less pillaging and plundering, and we're gonna use the same sort of drive that we've had in UIS Aerospace to achieve that. So the plan for now is to have a reusable first stage rocket, which is taking something very difficult and then doing the most difficult thing you can do within that category of difficult thing. But we want to reuse the first rocket stage, put a satellite in orbit. And the reason this is important is that Norway very proudly brags that we have the full value chain with space, right? At the core, you need a place to launch your rocket, and then you need the rocket itself. You need a satellite to go on board that rocket. You need some infrastructure to receive data from that satellite. And then you need a service to provide to the user, like Google Maps, for instance. And Norway proudly says we have all those things, which is, technically true, but not really, because Norway itself does not have the rocket.
Yeah.
It is the only piece of the puzzle that Norway is missing to have sovereign access to space. Because we build satellites in Andøya Space, we have a launch pad is now launching orbital rockets, or they're at least attempting to, with UIS Aerospace. And we have the value chain. We're only missing the rocket. And in the geopolitical climate of today, nations are realizing that in order to own your own critical infrastructure, you need access to space. And that's like, every country should own its power grid and own its roads and, own its government buildings, which is part of the infrastructure. And in the same way, you should also own your own access to space, is what we're set on.
I love how you frame that.
And Norway has a tremendous capacity with what we've achieved in a very few years' time. Back when we found oil on the Norwegian
continental shelf,
yeah, and we, in a very few years' time, we developed something that's become a world-leading industry, especially with regards to safety and operations and logistics. A world-leading industry that is much more expensive than what it would cost to build a rocket, right?
Yeah,
if you compare the cost of, the largest man-made object ever moved was the Troll A platform.
Yeah, that's true.
400 meters tall. That was built here. I don't know where it was, up at Stord, and they built part of it in Kværnevik, I think.
Yeah, I think that's right. It's much taller than the Eiffel Tower even. So just for scale, 400 meters is quite big.
It's insane. And it was built here, and we do have the money. It's going to be a fraction of that to build a rocket. The technical difficulty is, of course, it's very, very, very hard to do. But we have some good ideas to how you can do it. So it's the technical barrier that's stopping you. But if you can build something like the Troll A platform, and if you can fund it, because that's really one of the most important steps. Sure, you could build anything, but you need the funding to do it. So if you can fund something like that, it is in our opinion that you could just as easily fund, or more easily, a rocket company that's gonna, it's gonna cost about $1 billion, of $100 million to put a rocket like that in space. But with the investment capacity that you have in Norway, and especially with this vast wealth that we've built up by pumping fossil fuels out of the ground, it's under our impression that you should at least use a fraction of those resources to build something that can make a truly sustainable future for the world through space technology. And that's our mission in Space Lab, is to enable that access to space to Norway, and to build that future, and to build a new industry in Stavanger and in Norway that is producing rockets and putting satellites in space, because that's a huge market too. If you're looking at the value of a space company like that, if you can reliably send satellites to orbit for people, you have $1 billion company. And that's what SpaceX does, that's what Rocket Lab does. All these companies that are now incredibly trendy, it's one of these super trends. And that's what they're doing. That's what they're providing as a service.
Yeah, and I recently saw, speaking of SpaceX, that about, I think, if I'm not getting this wrong, about 80 or 85% of their revenue is now coming from Starlink. So basically putting satellites in space. So there's no doubt that there's a tremendous market here. And Norway should definitely have a piece of that.
Yeah, and SpaceX has positioned itself in an incredible way. What they've done is really impressive, because they own their whole value chain, right? They produce their rockets themselves. They have the rockets, they have the satellites, and they provide the services to the end user.
Yeah, complete vertical integration.
Yeah, exactly. That is massive, and the numbers for how many, I think around 80% of the world has no cell coverage. And if you can give internet to all these people, you're doing, like, business wise, and as a business strategy, you're doing something that's really unprecedented, and really huge. And that's what they're seeing in SpaceX. If they can own their whole value chain like that, it's going to be the biggest IPO, the biggest company ever to go public is estimated at, like, I think, 1,500 billion dollars.
Yeah. And most likely
Yeah.
this summer, we'll see if it actually goes through as planned. But it seems like July this year, around that time, it's most likely will happen.
And most likely that is because SpaceX is raising money to build data centers and mega constellations in space. That seems to be the reason, at least from what I've heard, is that that's the reason they're raising these 1,500 billion dollars, which is astronomically
It's astronomical,
astronomical sums.
yeah. Really fitting in the context. Yeah, I think
Yes, indeed.
one of their first customers in terms of data centers in space is also Google. So you have a major customer there. I saw some tweets from Sundar Pichai, the CEO, between him and Elon. So it seems they will probably be one of the first customers in that regard. And probably they will put some part of Colossus, maybe Colossus 3 or something for XAI in space as well. We'll see. What steps do you think are between now and launching satellites from Norway using a Norwegian rocket? Maybe do you have some thoughts you can share on the intermediate steps? And also, maybe you can share some more about what's happening mid 2026 also for you. It's not just SpaceX who are having great things happening this summer, but also you guys. Maybe you can share a few more details around that.
First of all, for us, our most important job now is fundraising and developing the concepts that we're gonna be using, and we have a good idea of what we're gonna build exactly, but making sure you have the full picture and planning out for the concept of operations for how you're gonna launch these rockets and recover them and then refurbish them and then launch them again, and the whole sort of production chain. And then immediate first steps for us in Space Lab will be to build and test the orbital class rocket engine that we're going to need on this rocket, because the engines are really the hardest part of these rockets. If you can make an engine with the control systems you need and producing the thrust needed for that amount of time that is required, then you've solved a big part of the problem. So for us, that's gonna if we can make that engine here in Stavanger and test it, that will unlock much of the later parts of what's to come. So that's really what we're working on these days in Space Lab, is this engine. The engine is actually going to be called Ragnarok,
Hmm.
which we like a lot. And I've already had some people tell me, "Well, isn't Ragnarok the end of the world in the Viking lore?" And I say, "Yeah, well, it is, but it's also a symbol of a new beginning."
Yeah.
It symbolizes rather chaotically through the end of the world. It symbolizes the new beginning, but that's not what we are focusing on. We are obviously we just first of all, the name is really cool, and then the Ragnarok as the symbolism is what we'll be focusing on. It's a new beginning for Norwegian space activities if you can build the ships too that are needed for this new technology to emerge out of Norway. A slogan of ours in Space Lab is that our ships have changed, but our spirit remains, and that's the spirit of exploration and the spirit of Norwegians having ships to go places is nothing new. It's just the ship has changed.
Yeah.
But we're still going to be working on that. So that's sort of our immediate steps to make the rocket a reality. And then now in 2026, personally, I'm in a phase where I'm also leading UIS Aerospace for a time until my replacement will be stepping in from the summer. And until then, we're trying to have a flight ready Phoenix 2 rocket, which we can then launch from Andøya to space in 2027 is the plan. So I'll still be Space Lab and UIS Aerospace are doing Phoenix 2 as sort of a joint venture, which basically means Space Lab will be helping out for as long as it needs as long as it takes to get Phoenix 2 in the air. And we'll still be in the mission management team and so forth to help out, make sure that UIS Aerospace reaches that goal of launching the rocket to space. And then I'll be stepping down from UIS Aerospace and focusing solely on Spacelab. UIS Aerospace will continue, especially with this Norstech rocketry challenge that will be in Andøya Space, focusing on that, participating there, and doing the most important thing in the world, which is beating NTNU at the competition. And there's a running joke we have in UIS Aerospace. A shout out to Propulse NTNU. And that's really what we're going to be focusing on for the coming time. We're going to be building a really big rocket at the University of Stavanger, and the engine tests are going to be pretty cool because we're developing a type of rocket engine that, to our knowledge, has never been made in Norway before, which is an electric pump-fed rocket, and has only been used on one rocket to space, which is the Electron rocket made by Rocket Lab in New Zealand. And that's sort of the only one, I think, that has made it to orbit. We obviously will be going to 100 kilometers, but it's still a very big step up in complexity from what we're used to in UIS Aerospace. So we're, just yesterday we ordered some parts for 300,000 kroners, and that's just the batteries and no, that's not even the batteries. That's just the motors and the management systems for the electrical parts of this engine that are going to make the pumps spin. And we haven't even started on the combustion chamber yet, ordering that. So it's a step up in complexity, but it's also something that the organization is really motivated to do. And it's going to be hard, but it's going to also, if and when it works, we're going to have some pretty cool tests this year. In around April, May, we'll have a Berserker 400 engine, as they're called. Again, with the Viking
Yeah,
theme.
keeping with the Viking theme.
We'll have a Berserker engine that's going to roar to life and produce almost 2 tons of thrust in our little top secret test site at Veldepukk in Gandal.
Oh.
So that's going to be fun.
I'm curious, what led you to choose this pump-led design that also Rocket Lab has tried out before? What's sort of the line of argumentation for sort of going for that at a high level?
So we were considering many ways to get to space. And, the simplest thing would probably be or not really simple, but a simple solution would be to use a solid rocket, like a firework, and just go really easy on the payload and, bring a lot of fuel and just, very simple motor. It burns until once you start it, you can't stop it. Burns a solid propellant and it burns until it's done. We could have pursued that. It would be much easier than what we're doing now. But what we decided on was that, okay, we want to use liquid fuels, because with liquid fuels you get much more, you get more powerful engines with liquid fuel. You get more of what's called the specific impulse, which is a measurement of how effective your rocket engine is at converting fuel into energy it can use. And we decided that we want to pursue liquid engines because it's really the step forward, especially if you're going to commercialize and if you're going to give people experience that nobody else has. You have to do something complex. So that was the reasoning for going liquid in the first place. And it's cool. It's easier to motivate someone to do something that's cool and difficult than something that's easy and not boring. But like, come on, people have done it before.
Yeah, let's step up the game.
Yeah, stepping up the game, and then actually the math of a liquid rocket engine, if you're only using pressurized tanks to push the liquid into the combustion chamber, you need pretty big tanks. And if you have big tanks, you need to bring more fuel to lift that tank, and the and the more fuel you bring, the bigger the tank needs to be. So
Yeah.
there's diminishing returns really fast. Like you can bring twice as much fuel on a rocket, but you won't get twice as high.
Yeah.
The returns are diminishing to a point where you're actually going the wrong direction again, where if you have too much weight, your engine is not gonna be able to lift the thing.
Yeah.
So we figured out that to give ourselves the margins we need, because we are still in UIS Aerospace, we are still students, and we don't have time to necessarily make completely optimized versions of everything with regards to weight. To give ourselves margins, we need an even more powerful engine cycle to actually reach 100 kilometers space, which is our goal for 2027. And a electric pump fed rocket engines gives us those margins, although it is a little more complex and a little harder, and the fact that it's really cool and we wanted to do it. So those were that was the reasoning behind going for that more advanced engine cycle. Tim Dodd at the Everyday Astronaut has a great video that I think it's called "How Rocket Engines Work," and he describes these engine cycles in detail, and it's really intuitive and easy to understand. And what he's talking about with these electric pump fed rocket engine cycles are that they're the most powerful of the really simple engine cycles, because it's still very, you have a pump, and then you have electric motors spinning those pumps, and that puts fuel in your combustion chamber. But if you were to look at, for instance, a gas generator cycle of rocket engine, you're now using a small amount of fuel and oxidizer before it reaches your combustion chamber. You're burning that in a small rocket engine, point it at a turbine, which makes the turbine spin, which turns the pumps, which pumps more fuel. So you have like a circular dependency on a system that is, if you mess up the regulation, it's like a turbo on a car. It can run amok. It can destroy itself if you mess up the the regulation,
Mechanism.
the control mechanism, yeah, the control cycle. And that's much more complex. But so we didn't look at that as realistic for us as students to make. So we decided on an electric pump fed version to give us more margins, a little more complexity, but the performance we need to actually reach space. So that was the technical reasoning behind it.
Yeah, yeah. Thanks for explaining that. That makes a whole lot of sense. Maybe you can speak to a bit of the size of the new rocket. I mean, it's not built yet. You're still sort of in the design and architecture and testing and trying things out, but maybe there's a range to give people some sort of idea, some sort of view of what we're talking about, and maybe a range in weight, range in length of the rocket, and a few other sort of key numbers.
Yeah, it's going to be about 10 meters long, and 30 centimeters wide. So it's a step up from Phoenix 2, but it's not the doubling of size that we've had from year to year.
Yeah.
But it's a quite big rocket. I mean, it's a third of the length of the rocket that ESA Aerospace is launching from Mount Maya, trying to go to orbit.
Hmm.
10 meters tall, and ESA Aerospace is 30 meters tall. So it's, they have about 700 million euros invested or something like that. We have about 150,000 euros of investments in
Yeah.
US Aerospace, which is really a lot for a student organization. We have a team of 105 people working for free in UIS Aerospace. They're putting in their sweat and tears, and that's really, the blood, sweat, and tears that they put in is really what's making this whole thing possible. And I get a lot of the credit for that this organization exists, of course, and that it's working. But the reality is that you have people working as hard as me, and they're working year round to make these rockets fly, and they're as passionate as I am. I'm just lucky to be the one who sort of gets to talk about it. a lot on conferences and stuff like that. But the reality is that there's a big team behind us that are making all this possible. We're very proud of what we've achieved with the little money we have. In the beginning, we had almost no money, and we've been broke so many times I can't even keep track.
That's quite incredible, and it reminds me a lot about the humble beginnings and the strong mindset and drive for innovation and making things happen that we saw at SpaceX in the early 2000s. So a small, dedicated team with strong minds working against all odds to make it happen. And I think there's a lot of similarities between the two, and I find it extremely inspiring.
Yeah, there's no secret that we're heavily inspired by what SpaceX has done, and I've read many books about how that journey sort of unfolded in the beginning, and two really good books, When the Heavens Went on Sale and Re-Entry, is also very, very cool. It talks about how they made the reusable, how they actually reused the rockets. And we've studied that, and it's no secret we're not going to, if you're making a rocket company in 2025, and that's also one of our cases, is that you have to start off where SpaceX is today. That's sort of the template that everyone else is going to look at and be like, okay, that's because it's really shown what's possible, right? If you're not looking at that for inspiration, I think you're doing something wrong. So we think the reusable part, is really what's, if there's one thing you can point to that has changed the what we're calling new space, or this new space age that we're part of, it's that you've reduced the costs by an incredible amount by reusing these rockets. I mean, imagine if you flew from Stavanger to Oslo, and then right before you land, everyone needs to jump out of the plane in a parachute, and the plane ditches in the sea, and you can never use it again. That's what we've been doing with rockets so far.
Absolutely.
And economically, it's terrible. And it's been logical that way because we haven't had the technology to actually reuse them. But now what SpaceX is doing is they're changing the whole paradigm because they're allowing for those rockets to fly again and again and again and again. That's where we think you should start, and that's where we are going to start. Of course, we're not going to nail the landing the first time, so we don't have any illusions of that, but we don't have to either. As long as you put stuff in orbit, the landing can come afterwards. But the reusability has to be built in from the start.
Reusable rockets have always been this holy grail of rocketry, and it's just incredible to see what SpaceX has been able to pull off, both first in terms of the booster, but then also the second stage. And it's awe-inspiring, and it's absolutely showing that what's possible, and we need to build on that regardless of which country who's trying to pursue similar things. That's where you need to start. And speaking of reusable rockets and sustainability and competitiveness, what are some, or is it possible to speak to some key technologies or maybe design philosophies that you are prioritizing to achieve reusability?
So I'm a strong believer in the approach that I described to you earlier with UIS Aerospace, that we're testing things and seeing, you test it, you find out what went wrong, and then you improve on it. It's an iterative approach, and that's also, from what I understand, what SpaceX's success has been largely based on. Is, the before you had NASA, who had, it's a big government thing. They're going to the moon. The whole nation's, maybe even the nation's survival. Are we going to lose the Cold War, or are we going to win the Cold War? It depends on one of these rocket launches. So the risk you are willing to accept is very low, right?
Yeah.
You don't, the president is calling you. The president is telling you that you can't fail here. And that makes the whole, like, okay, they spend billions and they spent decades building something, and then it has to work the first time.
Yeah.
So you're really not moving as fast as you could be because you need it to work on the first time. And that's sort of the only thing standing in the way of a good plan is the idea of a perfect plan. And in
Mm,
our in
well
our
said.
I'm not criticizing the NASA for what they've done. They went to the moon, which is incredible, right? So it is a very good approach when you're doing it as a state organization. But what's happening now is that private organizations are also doing this, and their risk tolerance is higher because they're more focused on giving the investors money back, and so that time to market is very important for them. They want to do things fast, and the fastest way to do things is to fail early and fail often, but fail forward. That you're building a rocket engine, you make it exist first, and then you make it perfect later. And that's a key design philosophy that we follow, and that we will especially emphasize even more in Space Lab, is that we're gonna just build things and see if they work, and based on our engineering skills and our intuition and our instincts, and then you improve on it later. But the first ones do not have to be perfect at all, and that's often something that I think is stopping people a lot in their own lives. You
Yeah.
have this idea that it has to be perfect, but then you actually learn so much more and go so much faster if you're just willing to accept a little more risk and a little more to fail, and then figuring things out from there. And then on the more technical side, we really believe also that 3D printing and additive manufacturing is absolutely crucial to develop fast iterations, and making things in an iterative approach, the way we're planning on doing the way we are doing it. So that's also something we're going to be leveraging, is 3D printing. The 3D printers that we're using now for the combustion chambers of our Berserker rockets, they're 3D printed metal in a super alloy that is very makes very strong and very very good rocket engine combustion chambers. So that's something also we're going to be leveraging in Space Lab, is 3D printing.
It's quite impressive that this additive manufacturing through 3D printing, that's strong enough to withhold all the forces that's applied in this context. I mean, that's quite impressive. So is it used both for the actual, let's call it, the production vehicle that's actually going to space, or do you use it mostly in the testing phase where you're iterating through different designs and how it's going to look like and what would work and what's more efficient than other designs? How do you go about it? Is it both in production or mostly in testing?
It's definitely in production. Yeah.
Oh wow.
I mean, if you look at the rocket engines made by basically every rocket engine or rocket company in the world right now, their combustion chambers and injectors and stuff, there's 3D printing on those.
Oh really? Okay.
Oh yeah, because one of the key challenges of a rocket engine is that the combustion chamber, you can have 3,000 degrees Celsius in that combustion chamber. So if you're not cooling it, it melts, because
Yeah.
any metal will melt at 3,000. So what you do is you make very complex inner geometries that have internal cooling channels, so that before you put the fuel into the combustion chamber, you're pouring cold fuel into your engine and cooling it, and then you're putting it into the combustion chamber. And before, that was one of the parts where people would joke, this is, or say that this is rocket science. Where the old joke comes from, it's not rocket science. Is that one of the parts was, you had to make that without the technology of 3D printers, where you had to use very advanced techniques and welding, and it was terrible. I wouldn't be involved in rocket science if it weren't for 3D printers, because it would be very different and much more complex to produce things. So really, you're seeing even relativity space in the US is 3D printing its whole rocket. They're making the a tank, huge. You can see it on YouTube if you go look for relativity space. They're 3D printing their whole fuel tank.
Oh
So
wow.
the whole rocket is in principle a 3D printed thing, and of course the combustion chamber and the nozzle and everything. There are parts on there that are sometimes not 3D printed, but mostly it's a 3D printed rocket engine.
Yeah, it's definitely a game changer then. It's to a much larger degree than I was personally aware of. Wow.
We're actually speaking at a conference on for additive manufacturing called NCAM. It's going to be in Stavanger in March. So that's also a cool place for you if you're interested in that to come and check that out. We'll be presenting our latest rocket engine and hopefully some videos of us blowing stuff up at that conference. So that's cool.
That sounds great. Yeah, I would love to be able to go there if that's possible given the schedule. Speaking of different rocket companies worldwide, how do you see yourself competing and potentially collaborating with these established players like Rocket Lab in the US or other emerging European efforts? How do you think about that part of it?
I'll see what my advisory board sends me a message of afterwards and says about what I'm about to tell you. But I think openness and transparency is very important. And what I would tell somebody, investing in Space Lab is that we're not going to compete with SpaceX, at least not straight away. You're with the level of funding that you're going to be having in the beginning, it's naive to think that you're going to straight off the bat compete with SpaceX. You might not even compete with Rocket Lab to begin with. It's also a really impressive company, and they're moving up there with regards to launch cadence and the rockets they're building. What the positive thing is that there is a demand that far outweighs the supply in the market right now. There's a demand for satellite launches that is much bigger than what the supplier is at the moment for rockets. And the bottleneck actually seems to be places to launch from. So launch pads. That's something you're going to have to. That's something that's going to be a bottleneck, especially for Europe in the future. And so that's a positive, that the market is big enough for more players because space is going to be so big. And then you have the Norwegian component. I remember I talked to the director of space transportation at the European Space Agency, Tony Tolker Nilsson, and he said, and I'm paraphrasing here, so he didn't say this exactly in that way, but what I got from it was that Europe doesn't care as much about price, because in Europe it's such a strategic asset to us to have access to space. And the same thing that I was talking about, owning your own infrastructure like that, is such an asset to us that if you make a product that is able to go to space, a rocket that can deliver those satellites, you can accept that it's slightly more expensive in that sense than for instance SpaceX, which obviously will be ridiculously cheap because they're launching these Starship
Starships,
rockets,
yeah.
and which are reducing. I think it was in 2011, it was 1 million kroners to launch something in orbit, and in 2027 with Starship, it's going to be like 2,500 kroners. Is what Brage Johansen wrote in his report on the subject for Tekna some time ago. And that really, we're not going to give 2,500 kroners to begin with, but as long as we're close to that somewhere, it's and can work towards reusability and reducing that price, then competing with SpaceX on price will not be as important. And then of course we will be a competitor, but if you there's a lot of talk about Elon Musk and his philosophies, but if you listen to the guy and listen to some of the things he said with regards to this, he says, for instance, that patents are stupid.
Yeah.
Because you want people to be able to follow what you're doing. If it's truly important what you're doing, you don't want to stop people from replicating it to make the world better. That would be terrible.
Absolutely.
And that's sort of the mindset, like a plentiful mindset, that I hope people competing with each other can have, is that there's room for everyone. If you're pursuing something important, then more people should produce that, and you should be allied with the people you're competing with. And every potential competitor is a potential partner in that regard, and we should all help lift each other forwards. That's the That's the ideal version of it, at least. In reality, I know there's it's not always like that, and people aren't always like that. But that's at least the philosophy that we want to pursue. And we've had a sort of a rivalry with Propulse NTNU, where we're jokingly, saying we need to beat NTNU and go to space before them and stuff. And it's all, it's all a joke in its core, because we want them to succeed, and we know they want us to succeed. And the most important part is that we're building a STEM industry and a sustainable future here in Norway. And if they get to space before us, then I'm going to be super glad on their behalf. And a healthy rivalry is good, and it's necessary to advance. But yeah, we want them to succeed, and likewise we want ESA Aerospace to succeed with their launches from Andøya. That would be great for Europe. It'll be great for Norway, and then we want to come afterwards and make a Norwegian company and hope that that succeeds.
That's a great mindset for sure, and I feel that more people are taking that on as we're seeing more competition, just not just in the space industry, but also in industries. I would say across industries, you're seeing much more competition. So both collaboration, sharing best practices, and healthy rivalry or healthy competition between the players, which definitely helps drive innovation and keeps
Yeah.
the pace of progress high. You've been hands-on in various projects. You mentioned also this parachute system for rockets, Borealis, earlier. Is there some, or what's one technical breakthrough or lesson from those early student launches that still influences your work today? Is there some key lesson that you can point to that you carry forward today as well?
I think it goes back to the what I was talking about with regards to testing early, and getting the data that sort of is the proof for if your product is working or not. It's becoming more and more apparent to me over time that just trying something, seeing if it works, failing at it, and then iterating is so important. And that mastery of the failure in that sense is very important. More of a strategy that I can really think of, and that's that
Yeah.
iterative failure strategy, and then eventually leading to success.
I also believe, at least as per my understanding, that sustainability is a core part of Space Lab's mission. Maybe you can talk to me about how you're planning to address environmental impacts in rocket design, propellants, and perhaps also operations.
With regards to space exploration first, if you look at the potential for space exploration, for sustainability on Earth, there's counterintuitive parts to that. Like, why would you launch a methane oxygen rocket that it produces a lot of greenhouse gases, even water, which is a greenhouse gas, high enough up in the altitude? If you have a hydrogen oxygen rocket, you put a lot of those in the atmosphere. Why would you do that? And say, for instance, if you look at satellites and what they're doing for GPS, and a ship that before had to go, you were on a course, you have to adjust that course, you're using much more fuel, you're using much more diesel than what you're doing. If you plot in the GPS, you account for the curvature of the Earth, you go from A to B, where you need to go, you bypass storms, so you're not using a lot of fuel. I don't know how many millions of tons of fuel we save every day by just having GPS and having that as a service. It's in our opinion that the world is evolving and developing, and we can't stop that. It's Space Lab can't tell everyone to, everyone stop polluting, everyone stop doing greenhouse. Even if the West does it, you still have countries like China that frankly don't care as much and don't buy into the whole environmental thing as much as we do in the West. And 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 they're not going to stop. So what we need to do is to find new solutions to things. We need to move our infrastructure out into orbit and out onto the moon and Mars and other places eventually. We need to go and mine asteroids and planets for minerals that we need to produce electric vehicles, and not have child workers and and polluting the seabeds and polluting the air with those sort of activities here on Earth. And that's really the end. That's the vision Space Lab has. We want to enable that for the world. Norway has tremendous capabilities with regards to drilling in the North Sea. You could use that same competence, the same mindset, and the same technical expertise you could use to mine minerals in space, but you can't get there. So you can't. You don't do it because you can't get there. But with a rocket, with the correct space, a launch system, you could get there, and you could actually do things like Brage Johansen is very fond of talking about. If you first get to the moon,
Yeah.
getting back to Earth is only a fraction of the energy and the cost. Yeah, if you're there already. So that's really, again, you're asking people to come on a mission where we're going to find something out, and they're like, what are we finding out? Well, we don't know that yet. You might be venturing out into space to find out something that you still don't know what you are looking for, but you have to go out and look for it. And a great analogy is something I first heard Neil deGrasse Tyson talk about, and he spoke about a cave analogy, that we can imagine that we're all, cave dwellers in the Stone Age or whatever, and we live in a little cage, and in there we have everything we need. A cave, I mean, not a cage, a cave. And we live in this cave, and we have everything we need. We have food, we have water, we have entertainment. There are problems there. Everyone knows we're running out of resources because this cave can't sustain us forever. And then someday, some person finds a exit to the cave and comes back to the rest of us and says, I found an exit. There's a world out there outside of the cave. And then there's some people who go, yeah, we should explore that. We should send some of our resources, some of the food, some of the water into this new world and explore it. And then some people might say, but we haven't solved all of the problems we have here in the cave.
Yeah.
So why on earth would we go outside of the cave? And now us, in retrospect, we know very well that if they just go out of the cave, you have basically, compared to the cave itself, you have infinite resources out in the world than if you would hide in a cave. And that is what the universe is to our planet. We live on a planet in a universe which, from all we can tell, it's infinite. And that means infinite both in space and also infinite in energy and resources. So the whole question about, how will you justify the use of our resources on this planet to go to space? The answer is that we need to make sure that we use the resources for that space exploration in a way that is sustainable. And what we mean by that, sustainability, is, it's a word that's used a lot, but the definition of the word is that you're satisfying your own needs without ruining someone else's needs in the future to satisfy their own needs. And so as long as you make sure that you're following that sustainability in the true sense, unpolitical, sort of scientific sense of the word, if you're making sure you're truly sustainable in the way you explore space, because you think that eventually you're going to make up for it by some other technology, then I think you can justify the whole space thing. And we're going to look back at this as a species, and we're going to be like, well, of course we had to explore the universe because we found out that thing that we don't yet know what is, but we don't know what's out there, and we need to find out. And it's only by going there that we're gonna learn everything. Because I work with an advisor to our organization. Is called Pete Worden to Space Lab, and he's been the director of NASA at Ames. He's a podcast guest, by the way. You should host. He's incredibly interesting to talk to.
Thanks
And
for the tip.
he has been the director of NASA Ames, and he works on breakthrough initiatives. He's been a general in the UIS Air Force too, and he works for breakthrough initiatives. And what they're working is on finding extraterrestrial life. They're looking for it, they're listening for it, and they're going out and exploring to see if they can find it. So they have 3 different projects doing that. They have Breakthrough Starshot, which is a solar sail, a new type of spaceship that can travel like 20% the speed of light to go and explore distant planets. And then you have a Breakthrough Watch initiatives and a Breakthrough Listen initiatives, where they're sort of listening for this extraterrestrial life. They can't seem to find anything out there. They can only look at it. They can't go there, and look at it and feel it and truly, see it up close. And that's why you need space transportation, you need space exploration to actually go out there and see what's there eventually. So that's also something obviously more down the line for Space Lab. But a vision of ours is also that you should mine asteroids, and you should explore deep space, and you should put people, or at least robots to begin with, because
Yeah.
the risk is much less. I don't want to be launching people anytime soon, at least not for another, at least another 5 years or 10 years. But you could send robots, and you could find stuff out that could really help us here on Earth.
Yeah, absolutely. And I really love the analogy with the cave analogy that you presented. Completely agree. I mean, we need to explore, we need to be among the stars, and it's the only way to really truly know what's out there. And we will have a completely different perspective looking at space while being in space ourselves, and also be able to, with a permanent base on the moon, for instance, or a base on Mars, launching various kinds of probes and satellites, and also telescopes like the Hubble telescope and James Webb telescope and so forth. We'll only be able to push things further and learn more about the universe, and what's the purpose, why we're here, and maybe learn new physics along the way. We spoke a little bit about Norway earlier. I mean, we have some unique advantages for space activities. Our northern location, we have some existing infrastructure we spoke about in spaces like Andøya. But
Yeah.
what do you see as the biggest barriers to Norway becoming a true space nation? And how is Space Lab helping to address them? Are there some elements that we haven't touched on yet that you want to mention in that regard?
There's or the 2 big barriers that I think about a lot, and that one of them is political. One of them is that in Norway, you're not incentivized to build a large company, because you're going to be taxed so heavily by owning a stake in that company, that investors are going to be like, why aren't you going to Sweden, or why aren't you going to Finland? Why aren't you going to these other countries that are also ranked as, the best countries in the world with regards to living standards? Why aren't you going somewhere, Ireland or whatever, where that would make more sense for you as a company to go there? And you don't have a good answer for it, unless you're doing like Space Lab and you're saying that you want this to be a Norwegian capacity, and that's sort of one of the requirements. Okay, but then you have no choice but to do it in Norway. But I think that's really one of the big blockers. In Norway, you have this formueskatten, which is a tax on unrealized gains. I think taxes are great. I want to be one of the biggest tax contributors in the country one day if I can. But there's a difference between taxing people on money they've already made, and taxing them on something they haven't made yet, which is what formueskatten is doing the way it is now. And if I make $100 million, and I want to buy a Ferrari and a new villa, I think I should pay big taxes on that, right? I almost think you should pay so much taxes on that you don't need a Ferrari, you don't need a huge house. But if you have an idea and you have money in the bank to realize that idea, especially when it's something like, building a sustainable future, the reality in Norway now is that if I make a company and buy machines for, millions of kroners, and not making a single crown in surplus, like your business is not profitable yet. You are personally, it's not the company even, it's you personally will be taxed just on the value of that company, what you have in machines or whatever. So not the revenue. you will be taxed on that. And that is a huge blocker. And I genuinely don't understand. I try to understand. I try to talk to all sorts of different people. And I like to see myself as in the middle somewhere in the political scene. And I listen, a reasonable argument is a reasonable argument wherever it comes from. And I
Agree.
really don't buy into the polarizing of the world that's happening right now, which I think is really bad for us to not be talking and sharing ideas across the political spectrum.
Yeah.
But I really, that's one of the things where I'm genuinely trying to find good arguments for why would you do it that way. And the only thing I can find is like, okay, you want to go after the rich people, and it's like it doesn't necessarily work that way. I mean, you have people that are sort of frowned upon in society because they're very rich, and then you look at how much taxes they're paying, and they're like paying the equivalent of taxes for 1,000 people or something like that, which is going straight to our healthcare system, straight to our education system. And of course it's creating a difference. That's also one of the arguments, is that it's creating a sort of societal hierarchy and a difference that can be polarizing. And I get that 100%, but make the tax come from somewhere else. I really genuinely don't need or have a desire to become rich from what I'm doing in Space Lab. I want the freedom to pursue the work that I want to be working on. And I like to surf and be out in nature and work out, and I want to be free. I want to be able to do those kind of things. I don't need to be tremendously rich, but I think you should, as a society, have the possibility that people can become very rich, and not just generationally that they inherit their money,
Yeah.
because it's an incentive for people in society to work hard. And some people are very motivated by that. And that is very positive for the rest of the country. So I think something should be done. It shouldn't be eliminated, but or maybe it should, but it shouldn't necessarily be eliminated. But something needs to be done about the way we're punishing startups here in this country for existing. And big companies, when they pay such incredible amounts of formuesskatt, and everyone thinks that it's hurting the millionaires and the rich people, but in reality it's hurting society. If I'm not mistaken, France had the formuesskatt, like the tax on unrealized gains, and then I think they abolished it. And the reasoning was, I saw a study somewhere that they were gaining 47 billion euros in taxes every year, but they were losing 60 to sources that were harder to measure, but they were still there because businesses are moving abroad. They're just going to take their business to Switzerland or some place where it's at least lower, or just not existent at all. What I took away from it was that they found out that they lose more money as a society by having the tax than what they could be gaining by not having it. And if you look at companies like Spotify in Sweden, Spotify wouldn't exist in Norway because it's way too wealthy. The people owning it would be paying so high taxes that they would definitely go somewhere else to have that company. And then in Finland too has a great startup scene. And I think we should look to those countries and like Norway is good at, learn lessons from what works well. And I think it is not doing Norway any favors. And I think that's a big barrier for Norway is politically you have this incentive for taxing something that isn't there yet, which I don't understand. And I'd love to have a talk. If somebody listens to this podcast and has a good argument, please send me an email or contact me on LinkedIn or whatever, and let me know what your arguments are, because I'm genuinely curious. But so far, I haven't heard anything that makes sense, other than what feelings are connected to it. And then the other barrier, I think, also is that, and it's probably related to this and this tax on unrealized gains, is that we don't really we don't have the same sort of investment scene in Norway as we do in other countries. There are, of course, places you can go to get investment, and you have some state-owned, investment bureaus like Innovation Norge and those kind of things, and that's great. But now, I mean, now they're even cutting back on that, and in I do believe that if your company, if your product is going to survive in the long term, you can't rely on state funding forever to make that happen. So you should really have private equity and, venture capital, organized investment that goes after supporting startups and supporting companies that are growing to scale up and build. That's something that is, from the little that I've been involved in that so far in Norway, is what I hear from people that know more about this than I do, that Norway is not really as vibrant as the investment scene you have in many other countries. So those are two barriers that I think could be stopping a company from, like Space Lab, from achieving that. But I mean, if you're being stopped by a barrier, you're not going fast enough through it, is my opinion. If you meet a barrier, run faster, or find a way around it, or find a way through it, or over it, or whatever, under it, if you have to. We're going to find a way to make it happen. And that's also, like, one of the most important factors of success, is that having grit and determination, is deciding beforehand, either through sheer ignorance, or deciding on it beforehand, is that you're just gonna not care that it's a bumpy road ahead. You're gonna push through either way, and you're gonna focus on that goal, and there's gonna be hurdles. I know there's gonna be great hurdles that are gonna make me question everything, and the only rule is that you don't quit. You fail and you try again until you have the result you want. And then, of course, it shouldn't come at the expense of other things you're trying to achieve, and having, friends and family, and stuff like that. But I do believe that if you look at yourself and see what you think your capabilities are, and then just have that grit and determination to not give up, then I think the barriers that we're facing by making something in Norway, the positives could outweigh those barriers by far, and
Sure.
we'll find a way through them.
Two comments from my side. I saw this interview not too long ago with Jensen Huang, the CEO and founder of NVIDIA, on Joe Rogan's show. And one of the things he said was, if he knew how difficult it would be and all the struggles they would have to build NVIDIA, he would never have started. So I think
Yeah,
there's a lot to drive, consistency, hanging in there, resilience, but also ignorance can be great positive,
yeah.
because
Ignorance is bliss.
ignorance is bliss, and it can definitely
Yeah,
really help you do incredible things. Because, as he says, and a lot of other people has, of course, said throughout the years, that if you knew how hard it was going to be, then maybe you wouldn't have done it. So it
yeah.
can really be a great thing.
The positive thing is that nobody can know how hard it's going to be, because life is I mean, it's so complex that even the smartest person in the world couldn't account for every possible thing that's going to happen along the way. So of course there are people that are smart. Either Magnus Carlsen, he can think like 11 moves ahead when he's playing chess. I
Chess,
can
yeah.
think like two moves ahead, or whatever. And some people are like that, but even those people, it's limited how far you can see into the future, because you don't know
Yeah.
what's going to happen.
So many
And the
moving
only thing you can
parts.
do is, yeah, you can position yourself in a way that you can have good luck.
Increase your luck
And
surface. Be prepared, and
yeah.
yeah, capable.
Exactly. Yeah, and then there's the fact with the technical difficulties like this, or big hurdles, or big goals, that as long as you know what they are and you aim at them, you should, of course, be thinking about. You shouldn't be not thinking about these barriers, but maybe you should focus on the ones you have right in front of you, in this room with you right now. Right? What are like Focus on the ones that are there now,
The
and then
next
you can
couple of
figure
steps.
out Yeah, don't think too far ahead, but also don't you have to think ahead. But there's a balance there that's important, and I mean, total ignorance is not the solution, but worrying too much is not the solution either. At some
Yeah, it's
point,
just
you
going to
have to
bring
do it and
anxiety,
try it
and
now.
yeah, absolutely.
Yeah.
Yeah, I also want to bring across one comment connecting the two, or attempting to connect the two areas you mentioned earlier. I think given this unrealized gains tax and the fact that that leads a lot of people to seek opportunities in other countries, it also leads to the creation of fewer companies, not just companies that have already started, but companies that could have been started by people who wanted to pursue that kind of life, the founder life,
Yeah.
and trying to create something. Knowing the difficulties, they may choose to do something else, which is not good for
Yeah.
society. So that's one. Another point I wanted to mention is if you have a very thriving in innovation and startup ecosystem, then you will have a lot of people growing their business and at some point selling it, doing an IPO, maybe some merger. What happens then is that cash is released. And those founders then very often become angel investors or do venture capital. And then you get a very healthy venture ecosystem. And since we don't have a lot of exits, as we see, for instance, in Sweden, which have much more unicorns than Norway, for instance, they have a much more healthy venture ecosystem, which then fosters the next generation of companies. And then you have like this positive cycle, reinforcing cycle with money flowing in back into the system to create new value, new workplaces, new companies that scale, that then are being sold, that then feed the next cycle. So I believe that the 2 points are actually connected. The two barriers are actually connected. And by solving one of them, we probably will solve both.
I agree with that, and that's a great reflection that I hadn't thought about. You know, the fact how it's circular and it reinforces that cycle. That's a great point, and I hope some politician listens to this podcast and gets their mind changed on, maybe I'm actually not, maybe I'm supporting something that's more ideological, which comes from a great place, right? It comes from the fact, the feeling of wanting equal equal outcome is natural to think. But then what you should really be focusing on is society's equal opportunity,
For sure.
and not necessarily the equal outcome that you're going to go after, go after the richest people and take from them and give to those who have less and distribute it more. It's just making less for them to distribute
Yeah,
in the future, which could be, I mean, that's what's harder to understand, is that the whole, what you're distributing into society, you don't have to pull anyone down by bringing someone up. You can bring everyone up by just, increasing what you have to distribute.
rather than lowering the roof, you can raise the floor, basically. You mentioned very earlier in our conversation that as a computer science student, that's how you started out. And I was just curious if, or if it has, how has your background in software influenced your work in aerospace, if it has in some way? Has there been some benefits to your background in areas like maybe flight software or maybe DevOps for rocket testing or maybe autonomous systems or something else? Or maybe there has been no benefit. I'm not sure, but I was just curious to get your thoughts on that.
First of all, there's the direct application. There's, for instance, that, in my bachelor thesis, made the I was on the team that made the recovery system, the parachute system for the Borealis 1 rocket, and programmed the graphical user interface, the control system that talks to the rocket, programmed that. So definitely, there's been a direct correlation. And if there's people who were at the Borealis launch listening to this, and they're probably laughing now, saying, "Ha ha ha! That what bullshit! We coded that the night before the launch in this cabin from the 1700s with a generator running in the background." And that's true. We did code it, the graphical user interface and everything. Much of it, we finished it the night before the launch with no power, no running water in that hut while we were out
Just in
on the
time
launch site.
delivery.
Just in time delivery. And I'm self-taught with all the things I know about rockets, I haven't learned in school. In the University of Stavanger, you have great computer science courses, you have great electrical engineering courses, great mechanical engineering, but you don't have any aerospace degrees. So what we're becoming good at in UIS Aerospace is sort of being good at many different things. And the knowledge is not, I mean, sure, I have a degree in computer science, but I've been working as much with mechanical engineering, understanding how to produce things and understanding how the different loads and stresses impact the system than I have looking at coding and writing code and building data systems. If you're a founder, if you're an engineer who's gonna build a product, you need to understand how that product works. You also need maybe to understand how that fits into the market that you're trying to put it in. So you have to understand that market and what's important for them. So it's more of a jack of all trades situation than it is being the master of one. So definitely the course I did at the University of Stavanger in computer science was great, and I learned I learned to code, and I hadn't done much of that before. But the important takeaway there was the basic physics and the basic mathematics that you learn to then have as a foundation for what you're doing. And I'm not gonna sit here and lie to you and tell you that I'm great at math or even great at physics, but the intuitive understanding and instinctively being able to see a system and understand the system, that's also something to be good at, right?
Yeah.
And when you're, especially as a founder, if you want to get a good job, you need good grades. But if you want to be a founder and make your own company, you have to be good at whatever you're doing, right? And that doesn't necessarily always mean being the best the best engineer or the best mathematician at the table, but it does mean you have to know your own limitations and you have to know where to get that knowledge from.
Sure.
And that's something we're getting pretty good at. And what I'm personally good at in this organization is especially the rocket engines themselves, along with the co-founder of Space Lab, Jørgen Hammervoll, which is really good at rocket engines. We're not necessarily specialized in all of the things we do. We just do them all quite well enough so that it all fits together.
Speaking about building up the space capabilities across Norway for the new space age that we're entering into, it's important to be able to find people to recruit and be able to recruit sufficient amounts of people to accelerate Norway's space endeavors. And it would be great if there was rocket engineering or aerospace engineering degrees, independent degrees, just focusing on that across all universities in Norway. But do you think your efforts through UIS Aerospace will lead to this being initiated at the University of Stavanger? And if not, how far off is it? And what's required to get it established, in your opinion?
So I was on the podcast of the prince principal, yeah, principal of the University of Stavanger, Klaus Moen, together with Ole Dokka, the director of Spaceport Norway, and we talked about that there, and so I sort of naively, Ole and I were like pushing him, come on, make a aerospace degree education at the University of Stavanger, and he explained to us, something that in retrospect makes perfect sense, is that they're basing the studies that they provide at the university off of what they think people can get jobs as. So if Klaus Moen is to make a aerospace engineering degree at the University of Stavanger, he needs a company that can actually give those people jobs, and he needs an industry in the region that can actually give people jobs. And so that's where I think personal responsibility comes in as one of the most beautiful things in the world, is that if you want something done, you have to assume personal responsibility for that. So we really want an aerospace engineering degree, and I'm going to be a little jealous of the people who get their aerospace engineering degrees from UIS in the future. But I really want that to happen. But the way I'm going to contribute to that is that we're going to make a space industry in Stavanger, and then we're going to support the university and keep through Space Lab, and then it'll be it'll be inevitable. If those things succeed, it'll be completely inevitable that the University of Stavanger offers an aerospace engineering course. And I really hope that happens.
Keeping on that thread for speaking about students, at the end, I wanted to ask you, for young students or perhaps aspiring leaders listening who might be inspired by your path, from founding a student organization to now running a commercial space company, what advice would you give on getting started in aerospace, building teams, and pursuing ambitious goals?
A really important aspect of it is to you can prepare and you can think a lot about things, but you have to know when to take a leap, when to trust the process of it. And you hear that being said, trust the process, but what does that actually mean? If you're climbing with a buddy, you're attached to a harness, you clip your rope in, at the top, you clip your rope in as you go, so that if you fall, your buddy will catch you down below you. And when I climb, and I've been climbing for years, I'm still scared sometimes when I go up there. And then as I'm climbing, what's important for me is to remember, okay, I'm hooked in. The equipment I'm using is going to take my fall if I fall. So I now have to decide to trust that equipment. And then if I fall, the equipment's going to catch me. And so what I would advise to young people starting out is that the equipment I'm talking about in life, or if you're doing a startup or whatever, the equipment is yourself and your own belief and your own ability to support yourself. And I think that's a very essential component as to where confidence comes from. It's the fact of knowing that if things go wrong, I will be okay. I'll be all right because I have other things I could be doing. If you jump for that hold and you fall, the rope is going to catch you. So finding out whatever that translates to in your life and build that confidence. And there's two things that they point to with founders that they have that often distinguish them from the rest of the population. I think it's something like 90% of them have experience with either martial arts or through the military. And that represents something that, in the military, you're taught to fend, to fight. In the martial arts, you're taught to fight. And you're taught that if you get beaten down, you get back up and, dust yourself off and get back at it, get back in the fight. And I think that's something that's essential. I think the military is a great place for young people to build character in a way that you don't get from, unless you seek it actively through, for instance, martial arts. You build a character that is essential for success in business by being, not scared of failure, because you're gonna get yourself back up.
Well said. Well said. All right. I think, let's end on that note. It's been a pleasure talking to you, Daniel.
Thank you so much.
How can people reach out? Where can they find you online?
Spacelab.tech is our website. You can go and look at our rockets there. And then on Instagram, we also have a Spacelab account. Go look for Spacelab. If not, you'll find it through the website, spacelab.tech. We'll try to post our rocket engine tests, and we'll make sure to show people what we're up to when we're doing cool things.
Awesome. All right. Thank you so much for joining today.
Thank you.
If you appreciated that, then click here for more content like this. Go on, click it. And don't forget to subscribe. Be well.